Hi everyone, welcome back to Coding with Bharat channel. So the topic for this week that we are picking for attempting problems on is 2D prefix sum, right? So yeah, let's directly jump into the topic. So before starting, please like the video, do share it with your friends and subscribe to the channel if you are new here, right? Okay, so going ahead, 2D prefix sum. What is the problem that we are trying to solve here, and why is this a more efficient way than a general brute force? So the problem at hand is, let's say we are given a matrix like this, right? So you can see here, we are given a 3 into 4 size matrix. Now, if we are given this matrix and we are asked queries like, take a sub matrix out of it and find out the sum of the numbers in it. So as an example, if I take this sub matrix in and I ask you, okay, what is the sum of this sub matrix? In the brute force way, how would you go about it? So you would iterate on all the rows and the columns of this sub matrix and find the sum. So 7 plus 1 plus 2 plus 1, which is 11, and you will return it. So in a way, if you have your r1 c1, which is the top left, right? So let's say this position of this is r1 c1, position of this is r2 c2. Then you would proceed by running a loop of I from r1 to r2, like going over all the rows, running a second loop inside it from c1 to c2, going over all the columns, and adding all those values into a answer variable, right? So if I talk about brute force, it would look something like this. So for I equal to r1 to r2, for j equal to c1 to c2, add to your answer matrix of ij, right? So and we'll declare answer as 0. So basically start with 0, go over all the elements and just add it to answer, right? This brute force, if you think about, is n square in worst case. Like if every query is says you to calculate the answer for the entire matrix and it's a huge matrix, or even if it asks you a few less rows or a few less column of the entire matrix, then for every query you would need to go n square. So if I talk about time complexity for q queries, it would become q into n square if there are q such queries with different r1 r2 c1 c2, right? Okay, so this is the problem at hand, like finding sum of sub matrices very quickly. And to solve this faster in a more efficient algorithm, we have prefix sum in place. So this prefix sum idea is very similar to what we do with 1D array as well. So if you have not checked 1D array completely out, go through that video once, that is there on the channel. I'll just brief the idea so that we can use it now in 2D one as well, right? So if the same problem was given to me for a 1D array, right? 4, 1, 2, 3, 5. And let's say LR is given that, okay, you need to find the sum for any sub portion of the matrix. Then what was the idea? The idea was that we computed a cumulative sum of array. So we said 4, 4 plus 1, 5, 5 plus 2, 7, 7 plus 3, 10, 15, and similarly 22. With this prefix sum in place, right, cumulative sum in place, we could say for any L to R, the sum is equal to, take sum of all the elements till R. What is sum of all the elements till R? Prefix sum of R, 15. You can see also sum of all of them is 15. That is what cumulative sum is. Minus, remove all the sum of elements before L. So go to L minus 1 and remove that from it. So we'll get 10. And you can see 2 plus 3 plus 5 is in fact 10. So simple idea, take cumulative sum and then take everything till the rightmost, remove everything on the left side of what we don't want. Same idea we use for a 2D matrix. So let's go over that. Let's go to our matrix and see how 2D prefix sum would look like. So let me remove some extra things here. So yeah, okay, and these things are not required now. Cool. So I've tried to make it a little cleaner so that it's better to understand. So similarly, say with a similar looking idea, what we want to do is, first of all, at each index, we want to store sum of all the elements from the start of the matrix. So start of the array was a little easier. Start of the matrix is also in a similar fashion the 0 0, which is the top left element. This one. So basically, if I am at 1, this 1 comma 3 1, then the value that I want to store here is sum of all the elements from the start till this point. If I am at this 4, then also I would like to store the sum of the start from start till this 4. If I am at this 3, then it would just be 4, 5 and 3. So basically, for any particular element, you want to look at the sum matrix sum from the start. Okay. How do we go about calculating this easily? So if you look at what I want here is sum of three elements in all the above rows summed together, right? If I want to calculate the value for any L comma R, I would want to calculate for all the rows value till R and then sum those up till L rows. That is what the value at L comma R should be. So if we break it down, what we want to do is first of all do prefix sum on rows. So let's do that. So let's do prefix sum on rows. So I will get 4, 4 plus 1 5, 5 plus 2 7, 7 plus 3 10. Then 5, 5 plus 7 12, 12 plus 1 13, 13 plus 4 17. Similarly 3, 3 plus 2 5, 5 plus 1 6, 6 plus 9 4, 15. Right? So I'll just fix the screen so that things are completely visible. So this is what your row wise prefix sum matrix would look like. So now for calculation of this one, I wanted first row sum of first three elements, which is here. Second row also sum of all three elements, which is here. Similarly for this below one, I would need third row also, which is here. So in a way, now what is left to be done is do column wise sum as well. So let's just do column wise sum as well, prefix sum as well. So yeah, I will remove this brute force because this is done already. Okay. So let's do column wise sum now. So we'll start with 4. 4 plus 5, 9. 9 plus 3, 12. Let's do the second row also and we'll verify. So 5, 5 plus 12, 17. 17 plus 5, 22. Right? If you actually look at it, the value at this 7 should have been 4 plus 1 plus 5 plus 7, which is 17, which is what I'm getting at this place as well. Right? This sub matrix, if I talk about, it actually contains 4 plus 1 plus 5 plus 7, which is nothing but 17, which I've got here. Similarly, for till this 2, I would need this sum, which is again 4 plus 1 plus 5 plus 7 plus 3 plus 2, which you can calculate and it will come out to be 22. Right? So it seems like the idea is working. First do row wise sum, then do column wise sum. By the way, the other way around would have also worked. First do column wise sum and then do row wise sum. There is not much of a difference in that sense. Okay, let's just calculate the entire thing. So we'll have 7, then we'll have 20, then we have 26. Similarly here, 10, 10 plus 7, 27, 27 plus 15, which is 32. Right. So now, by doing row wise and column wise sum, at any index, I have the sum of the entire matrix from the start till this point. Okay. Now, let's say I want to know sum of any submatrix. How do I go about it? Right? Let's say I wanted sum of, sorry. Let's go back to this original matrix. Remove the extra lines so that we can make it cleaner. Right. If I want sum of a submatrix, how do I go about it? In array, it was easy. From start till the end, minus from start till before end. Let's do something similar here. From start till the end, that means this entire thing. Now, we want to remove extra elements. Where would those extra elements be? There would be some rows from the top that I don't need, some columns from the left that I don't need. So let's remove all of those. So I'll remove this portion, the rows that I don't need, this portion, the columns that I don't need, right? So entire thing minus the extra rows on the left, extra rows on the top, extra columns on the left side. But if you see some of the elements which are in the both row and column removed part, they would be removed twice. So I would need to add them back once. So actually, if you look at how would the formula go about if I want to calculate prefix sum from R1C1 to R2C2. So I would say take the sum or the cumulative sum till R2C2, right? Take all the elements sum till R2C2. Now remove these extra columns. How do you go about removing these extra columns? You remove out sum till R2 of column 1 minus 1. Column 1 minus 1 will tell you the extra columns that are there. So remove the sum of all the elements till R2, like row 2, which is the last, comma C1 minus 1. So all these on the left side would be removed. Similarly, remove the rows on the top. So again I'll say minus p sum, prefix sum till R1 minus 1 C2. So column will remain the last one, but row number would be R1 minus 1, like remove all of these on the top. Now, because some of the portion would have been taken twice, you need to add it back. So there would be plus add back the portion from R1 minus 1 to C1 minus 1, because if rows are also less, columns are also less, it would have been removed. All these elements would have been removed twice from my sum. So this becomes the formula. Like in 1D it was easy, p sum till r minus p sum till l minus 1. Here it's intuitive. It's still easy to understand. If you take a copy pen and draw the matrices, you'll be able to understand it. But it uses, this is known as principle of inclusion exclusion, right? That first you take the entire thing, you remove certain things, and if those removed thing had something in common, then you would need to add it back once so that it only removed once and not removed twice. So same idea here. We take the sum till R2C2, subtract the extra rows, the extra columns, and then add back the small square which was added again. Okay. So with this idea in mind, the question that we want to solve today for lead code is also exactly the same, which is range sum query. So just let's go through the question. So it says that let's say we are given a 2D matrix and we want to handle two types of queries, right? The first kind of query, actually only one type of query, which says you will be given the upper left corner R1 C1, row 1 C1, column 1, and lower right column, lower right corner, which is row 2 C2 or R2 C2. And you need to calculate the sum of the elements in the submatrix formed, or the rectangle formed by R1 C1 and R2 C2. Okay. So this is exactly what we have been solving so far for. So you need to implement a num matrix class where you initialize, and you have queries for this sum region which should be answered in O of 1. So if you actually see, our queries are being answered in O of 1 because we are just doing 2 minus and 1 plus, which is O of 1. Okay. Let's look at how the function signature is. So it says we'll initially be given a constructor. We'll be calling this constructor to do your pre-computation, right? So do your pre-computation here and store it. Then I would repeatedly call this sum region to get sum from for any particular region. And I need to answer this in O of 1. So these two functions you need to in a way complete. Okay. So let me go over the submissions that I had. So let's see quickly, add the code that I had made for this. So what I had done, I had created in this class, you can see a prefix sum matrix. So as the question said that our matrix is immutable, we should not modify it, right? There is a mutable version of it also where you can directly change that matrix. But since it says it's immutable, we need to keep a copy of it inside our class so that we can reuse it. So that is what I've done. So I have created this psum and I have copied my matrix to this psum array. Now we have n and m, which is the number of rows, number of columns. Now for each row, first of all, for each row one by one, I am doing sum of all the columns. So for each row, so I is equal to 0 to n, which is for each row, go through the columns from 1 till m. 1 till m, go through the columns and add the previous one, or keep on doing prefix sum. So I've said prefix sum from of ij plus equal to prefix sum of I j minus 1. So in the same row, previous one plus this new value, previous one plus this value. So cumulative sum. Similarly, do cumulative sum of columns now. So what I've written, for each column now, for each column, we'll go through all the row numbers from 1, not from 0, because 0 then minus 1 doesn't have anything. So starting from 1, so that minus 1 index has 0th element, right? And keep on adding that to get your cumulative sums. Okay, so with these two now, we have our prefix sum prepared. Okay, now we need to answer the query from R1, C1, R2, C2. So we'll use the formula that I talked about in the whiteboard as well. So we'll firstly initialize it with R2, C2. So R2, C2. We'll subtract left portion. We can only do this if R1 is greater than 0. If R1 is 0, then that means we are taking the entire thing till the 0th row. Sorry, row is for the top one. So if R1 is 0, that means we are taking everything starting from the 0th row till a certain point. Whereas if R1 is at 1, 2 or 3, we have some extra rows that we want to remove. So if my R1 is greater than 0, then I'll remove out all the rows till minus 1 and till the column 2 that I had, right? Till the last column that I calculated the result of. Similarly, remove from the right side, from the left side. So again, if column 1 is greater than 0, then remove row 2 comma column 1 minus 1. Lastly, if both are greater than 0, then only we'll have a rectangle at the top left which we want to add again because it would have been removed twice. So if something has been removed twice, add it back once and return the answer. Okay, so with this we got the question accepted, answering our query in O of 1. Great. If you have stayed so far, just make sure that you hit the like button And yeah, let's see you tomorrow where we'll take this concept. So this was mostly a concept and do a problem built on top of this concept. Great, then see you guys tomorrow.